Let's get a good color. You guys need a new color. We'll do orange today. Purple. Purple, purple. All right. Hey, Towers, can you do me a favor? Can you grab those two blinds and shut them, bud? As low as possible. There we go. Yes, sir. Yeah, sharpen your pencil if you need to. So basically, last night, you guys might have got to a problem called the density problem and said, uh-oh, wait a second. I'm not too familiar with this. But it wasn't really that tough if you think about it. Because the density property basically what the problem was telling you was, hey, take this number here, 7 3/5, and what I want you to do is take this other number, 7 4/5, and give me a value that's in between them. And basically, let's go to yesterday's lecture. Yesterday we talked about real numbers, guys. And what we did with real numbers is we defined the real numbers. And then from there, you guys actually were able to classify some of them. So if you look at these here, that's me talking in another video. Actually, that was me talking to you guys. But if you look at this, it was one of my classes. So if you look at this, we classified them. So this is saying, hey, density property is saying, hey, I can take two real numbers. Guys, what kind of numbers are these? Let's look at these in class. Well, they're real numbers, possibly, but to be a real number, it has to fall in one of these other value places. So, what? We have a rational number. And rational numbers are decimals or fractions. Remember, rational numbers are decimals or fractions that they repeat or terminate the decimals. So, therefore, this is saying, hey, these guys are real numbers because they're, like Peter said, rational numbers. So if we take these two values, density property says, hey, let's put this on a number line. And if I put these on a number line here, straight across, and say, hey, let's call this value right here. We're going to call that 0. Here's my arrows. Here's my arrows. And somewhere along this line in a positive direction, I'm going to hit 7 3/5. Also, somewhere along this line, Johnny, is another value called 7 4/5. Yeah, and you can see both these two, can't you, Carrie? So along this line, we've got these values here, Trey. And what this says is, hey, you guys are pretty bright. Any of you can see that you could pull any number if you work these out and say, hey, this is some value here. You can see that there are, maybe if I did it this way, guys, there is a value, let's just say 7.71, right? You can see that 7.71 is a decimal. It's got to fall in between here possibly. But also, I could say 7.72 is another value. So there are, and let's say 7.73. So pretty much there's an infinite amount of numbers that could fall in here. Does that make sense? I could plug in tons of numbers that could go in here, right? Yeah, absolutely. However, what's up, Grayson? Hold your thoughts until after this lecture. So you can place a ton of them in there, but what I want to know is what numbers absolutely 100% in the middle or right in between. And the way you solve that is using the density property. The density property says if I have two real numbers, you guys already told me that these are two real numbers. If I have two real numbers, the density property says there is a number exactly between those two numbers, smack dab in the middle. And the way that you solve for it is you take the first real number, 7 3/5, and you add it to 7 4/5. That's supposed to be a 4, not a 9. And now you divide those two numbers by 2. Why do I divide by 2? Yes, sir, Thomas. There's two numbers up there, and if I added them, I took the sum and divided by 2, I would find the what? The midpoint, right? I'd find the value in between. If I add both numbers, the sum, and divide by 2, I find the point that's in between. It's kind of like solving the average, isn't it, Hunter? Kind of like taking the average of the two. So let's solve for these. Well, 7 plus 7 are 14. And that's over 2. Don't forget, this is over 2. plus 3/5 plus 4/5. Well, 3/5 is 7. 3/5 plus 4/5 is 7/5 because 3 plus 4 is 7. All right. Well, the next step from here is to say, hey, Carrie, what is 7/5 as a mixed number?
1 and 2/5.
Yep. So now I have 14 plus 1 and 2/5. And Jules, what's 1 and 2/5 plus 14? What's 1 plus 14? 15. So I have 15 and 2/5. 2/5. That's my answer. But guys, I'm not done, am I? Sanjeev, what do I got to do, dude? Got to divide them by 2. Well, I don't have a calculator handy, so Mr. Hunter, tell me what I could do instead. Okay, so take this top number he's saying, hey, take the top number, and Zoe, let's put them in an improper fraction. Zoe, how do I turn 15 and 2/5 to an improper fraction? What's it become? Which is 75, 77 over 2, no, over 5, 77/5 over 2. Okay. So now from here, Jarrett, what could I do from here, dude? Divide by 2. Yeah, but that's kind of tough to do because I already have a fraction on top. So what can I do now? Instead of divide by 2, what else could I do? Or put that in other words, Abby. No. Multiply by half, but say that in a different way, Abby. No, it's still a half. You're absolutely right, Jarrett, but Javier, say it a different way. Flip this and turn it into its reciprocal, which is 1/2. Because 2 is 2 over 1. This is 2 over 1 right there. So now let's do the reciprocal. Well, Austin, you're up, man. Stand up behind you and work on the poster to solve 77 over 5 times 1/2. And Iris, you're up on the other board doing the same thing. Mason, you're up on the other poster doing the same thing. Actually, get on the chalkboard, Mason. You can do the chalkboard in the corner. Yep. Trey, that is the biggest pen I have ever seen in my entire life.
It's the only pen I have for now.
That is an incredible pen.
That is huge.
That thing, looks like you won it as a trophy.
I don't know where I got it.
It was a trophy. He's being modest. Good job. Okay, back to work. Back to work. Looking at what Austin, Iris, and Mason are solving for. Hey, let's look over. Mason, hit the lights real quick, dude. Mason, you're gonna tell us what you got first.
Oh, I don't
You haven't solved it, but Iris has. So Iris, tell us what you got. 77 over 10. So she got 77 over 10. Talk to us, girl.
So, wait, should I like explain it or should I just like?
Yeah, you explain every step.
Oh, okay. Okay, so, I couldn't really like do the cross multiplying thing.
Sure.
So I just did 77 times 1 and that's 77 and 5 times 2 and that's 10.
Yeah.
And then it was an improper fraction.
Yeah. Well, no. It's an improper fraction. So how did you get 7/10? 7 and 7/10.
Well,
10 goes.
times 7 is 70. And
Yeah.
then it was
7 and 7/10. And you got.
I got 77.
How did you get 100?
I multiplied 5 times 2 times 10.
How did you get? Oh, slow down. How did you get 77 at the top there?
77 times 1.
Is 77.
Right.
So 5 times 2 is 10. Okay, so you're starting right there. Scratch out that stuff below. Yeah, I think you just went. Yeah, just erase it.
It makes sense.
So you see now, you see now, Mason,
Yes.
you see now that, hey, I have 77 over 10, so what do you do?
Well, what do you mean?
Because you have an improper fraction, so what do you need to do?
Make it, or make it.
Show us how you do that.
Like,
77 over 10.
oh,
So 10 goes into 77 how many times? You got it, buddy. Great job. Box your answer. Austin, let's just make sure they're correct. What did you do? You rock. Great job. Guys, have a seat. Mason, hit the lights. So what they're telling us here, hey, we got this improper fraction. We flipped the reciprocal, multiplied 77 fifths by 1/2, and I got 77 over 10. Well, 77 over 10, because 10 goes into 77 7 times, I get 7 7/10. Okay, hey guys, guess what? We're not done. That is the value, but let's plot it on our graph. Let's go back here and say, hey, this value right here, smack dab in the middle, has got to be 7 7/10. And this is how you solve for the density property. Okay, you guys can pull out your homework and start working on tonight's work. Are there any questions? You please raise your hand. You got a question? Yeah, go ahead.